Here we go, guys. So in example number 8, we're talking about finding the exact values using our using the sum and difference of sine and cosine rules. So here we are on example 8. Find the exact value of cosine 7 pi over 12 using the fact that 7 pi over 12 equals pi over 4 plus pi over 3. Does that make sense? So for cosine, so for cosine of at A plus B, that means you're going to have cosine of A times cosine of B minus sine of A times sine of B. Does that make sense? So we're going to plug in our values. So we have the cosine of pi over 4 times the cosine of pi over 3 minus the sine of pi over 4 times the sine of pi over 3. Unlike addition, order matters for subtraction. So make sure your order is correct. Got it? All right. What's the cosine of pi over 4? Square root 2 over 2. Cosine of pi over 3? 1/2. Sine of pi over 4? And our sine of pi over 3. And now with fractions, when you're multiplying numerator times numerator, denominator times denominator, with a radical, with radicals multiplied inside together as well, correct? So we have square root of 2 times 1, which is square root of 2. 2 times 2 is 4. Square root of 2 times square root of 3 is square root of 6. 2 times 2 is 4. And so this would be your answer, but you want to write it in the least amount of characters as possible. So you're going to put over one denominator. Got it? Least amount of characters as possible. If you want to be a weirdo and factor out the negative square root of 2, you can, or square root of 2. But is that going to make a difference in the problem? No, it's not. Don't be weird. Call it a day. Okay? Since the pi over 4. All right, so now I would like for you to try this one. So we know that the end game here is cosine x, right? So keeping in mind the formulas that we used, what should we do? Somebody tell me. Mm-hmm. There we go. It's just the cosine of x. So tell me. So we have sine of then what? What's next? Mm-hmm. Perfect. Yep, just roll with it.
Do you have the council volunteer papers?
Somewhere over there.
We have to do them out and come back after that's there.
Mm-hmm.
It's for Apple. On the volunteer.
Waiting.
Instead of the sine of pi over 2 is square root of 2 over 2. No, it's not. It's just square root of 0.
1. Now, Anna, the cosine of pi over 2 is what? There you go. And that's how it goes away, and that's how we prove that it is. Pi over 2 is your 90, right? Yes. So do you see how we combine the proofs with the formula? All right, moving on. Hey, you two. Y'all talking by yourselves.
Wait.
What?
Cosine of 0, and then you have to go with cosine of 0?
No.
Wait, we're just trying to prove this?
Mm-hmm. Yeah, we were just trying to prove that this equaled. My bad. Oh, Miss Jones, my bad. Sorry. All right. Here. Suppose that sine alpha equals 4/5 for quadrant 2. Angle alpha and sine beta equal 1/2 for quadrant 1. Angle beta. Find the exact values of each of the following. Okay, so first we're going to do is draw our triangles. Okay, we are drawing our triangles where they tell us to draw them. The first one is drawn in what quadrant? Quadrant 2. If I have sine theta, if I have sine of an angle, that means that this is the what? The y. It's your vertical change, right? And 5 is your r, your radius. So I know that this is 4 and this is, that's badly drawn. Can't even that was horrible. Your x has to be, your x is negative, not your y. So we have 5, 4, and this is what kind of 3? -3. So this is alpha. Yes. Okay, now we're gonna do our other ones in quadrant what? It's in quadrant 1. In quadrant 1, I have sine beta equals 1/2. So what is the? It's y, and this time it's a little shorter because our y is only 1. Clearly, this is not drawn to scale. Okay. And we get square root of 3. Good job, Hannah. Now that I have the triangles, all it is a matter of me using my triangles. Okay, so up first, we have cosine of alpha. So which triangle am I using, red or purple? Red. So going to alpha, what is the cosine? Is what? Adjacent over hypotenuse, so -3/5. Yes? What's cosine of beta? There we go. There we go. Yes? All right, so now you are going to do cosine of alpha plus beta. Do you have all the information you need to do cosine of alpha plus beta? Yeah. What'd you say? Times is what they were saying, guys.
We did not say time.
They're saying times, guys.
Oh,
They're saying times, guys.
Yes. She's got me.
Toodles noodles. Have a good weekend. Are you ready? Okay. If you finished C already, go ahead and try D. What do you mean? You multiply? Your cosine, that's the value. Like the rule is, it's your cosine of your alpha, right? Times the cosine of your beta minus the sine of your alpha, sine of beta. That's the answer. What is cosine of alpha? The answer is -3.
-5 times.
Times. There we go.
Those are cosine A, cosine B.
You already have all your pieces.
It's like finding it before.
Yeah, we already found everything and now we could just evaluate.
Okay, wait. Riddle me this.
Maybe.
Why do we do?
Hit it, Joker.
We have to find Why do we do?
Because the formula says multiply. It literally says cosine times cosine minus sine times sine.
There's multiple. Wait, what? Look at all the formulas. They're like four formulas. Cosine A plus B.
And when you see cosine of A plus B, what do? No, we multiply. When we see that, that means we're multiplying the cosines multiplying the signs and subtracting. Because that's not the rule for times. Ugh, go look up the, I'm not riddling you Joker number 2, nothing.
No, make me number 1. Your camera picked that up, Michelle.
What?
It was vulgar language. What?
And remember
Three.
the 3.
Oh, yeah, because it said figures equal factors. We have a rating at the bottom. Is there another?
How'd you get
rule?
-7?
Is there a rule?
You can't combine.
So with sign, we just add.
The only way you could combine the 4 and then the only way you can combine it is if they had a, I don't know why my 3 became a 4. Square, -3 times square root of 3 is -3 square root of 3. 5 times 2 is 10. 4 times 1 is 4. 5 times 2 is 10. They're already common denominators. Yeah. You're not dumb. Just have a little brain fart. So sine of alpha times cosine of beta plus cosine of alpha times sine of beta. So what's our sine of A that was given to us? 4/5. Yeah. Well, you know, keep that.
Because the sign is right, if the cosine is wrong, it's a con. Like you saw the sign. Hey, girl, you should not be shaking your head. We turned it our. What if the school shooting one? What? What?
I don't have to think about school shooting. I have never done that. That is not what I said. That's describing how your rate gets closer to 0, flattens.
What's your stripper? All strippers take cash? Yeah.
Bye.
It's about like when sign.
I feel like y'all are just being ridiculous now, and I'm glad this is our last set of notes. All these lies. Oh my gosh. Anyways, I have never told you to be a stripper. Never told y'all to be a stripper. I'm just gonna mute this recording at this point. We're gonna let B equals cosine inverse X. Using other variables to substitute in for trig values is a good practice for when you're in calculus and you're doing U substitution for integration and derivatives. So we're gonna make that little substitution here, okay? So we make that substitution, what we end up with is actually sine of U plus V. Because if we let this be U and this be V. So now it becomes sine of U plus V. And so when we have these triangles, if this is our U, So at first we have u equals. So u equals 10 inverse of 1. In order to have a 10 inverse of 1, that means that your opposite and hypotenuse have to be the same number. Does that make sense? So it has to have a ratio of 1, which is why this is 1 and 1. Make sense? And so if this is 1 and 1, then our radius has to be square root of 2. No, Pythagorean theorem. It's 1 squared plus 1 squared, and you got to take the square root, which is square root of 2. Yes? All right, on the next one. So on the next one here, it says V equals cosine inverse of X. So if we're looking for the cosine inverse of X, cosine means you have your adjacent and your hypotenuse, right? So if we have our adjacent and our hypotenuse, we're looking for when V is X over 1. Because if there's nothing with the X, it has to be a 1. Does that make sense? Same thing here. This is 1 over 1. This is X over 1, which is, again, verifying that this is 1, 1, and this is X over 1. Yeah? All right. So if our radius is 1 and our X or our adjacent is X, what does our Y have to be? Neither. It has a square root. That's a good start.
Wait. It would.
Because how do you find Pythagorean theorem? And if I'm looking for a side, I have to subtract instead of add. And then take the square root. Mm-hmm.
So could you just take away the square root?
No, you cannot. That has to stay underneath the square root. Okay, so now that you have the values and you have the substitution, you have sine of u plus v, which means that you're doing the sine of u times the cosine of v plus the cosine of u times the sine of v. And can you easily identify those values? Yes. All right, sine of u. So I'm going to go to u. Its opposite is 1. Its hypotenuse is square root of 2. I'm going to go to cosine of v. Its adjacent is x. Its hypotenuse is 1. So it's just x. Cosine of u. Its adjacent is 1. Its hypotenuse is square root of 2. We'll clean it up in the end. Right now you can. Sine of v. Opposite is square root of all over 1. So now you clean it up. So 1 times x is x, square root of 2. And then 1 times, I don't even know what I wrote there. Can't even pretend.
It would just be the same thing.
Yes. 1 minus x squared over square root of 2. And the goal is to minimize your number of characters. And since they have the same denominator, I can write it all over.
And then times square root of 5.
So this is where I would assume, because normally you're not supposed to have a square root in the denominator. How do we get rid of that? Now, to me, though, this just seems redundant and makes more numbers and unnecessariness. But we're going to do it. And I'm assuming they're going to give you credit for it.
Over 1.
It's over 2.
We don't have to roll part of our 2 out.
Mm-mm.
Easy.
Nope. Just leave it in factored form. All right. We have one more example in part B, correct? So here we are. We have, I skipped it. There we go. Find the exact values of sine 2 theta and cosine 2 theta using the double angle formula. So the double angle formulas were the other set of formulas we learned. We learned for sine, there's only one double angle formula, but for cosine, there are 3. Okay, it does not matter which one you use, but I told you I like to use the cosine squared one. So that's what I'm going to model for you. Okay, so it says here, we have cosine theta is 3 over 5. So that means that this is my x and this is my r. And it's between 3 pi over 2 and 2 pi. So what quadrant am I in? 4. So I'm in the fourth quadrant. In the fourth quadrant, I'm going to have an x value of positive 3 and a radius of, radius is always positive, but therefore my, what is negative? My y, my negative 4. And this is my theta. Good? All right, sine double angle. Sine of double theta equals 2 sine theta times cosine theta. So all I have to do is use my triangle to find those values. What is sine theta? Negative 4 over 5. What is cosine of theta? 3 over 5. And now we're going to multiply everything. 2 times negative 4 is negative 8 times 3. 5 times 5. And there's my double angle value. Okay. Now we're looking for cosine double angle. So cosine double angle equals, and again, Ms. Jones's choice is 2 cosine squared theta minus 1. Especially if they give you your theta. Why would I admit your cosine? Why would I do more work? 2, what's cosine? 3 over 5, and I'm going to square it. What is 3 over 5 squared? That is not what that is. Which equals 18 over 25 minus 1, which equals close. Negative 7 over 25. I said you were close. If it was 35, then yes.
Wait, why did you get -7?
Common denominator. It'll be 25 over 25. Yes.
Wait,
What? Oh, it's too late, Andrew. It's too late. It's too late. You too, buddy. Yeah, babe. Because it's 25. It's 18 minus 25. If you have $18 in your account and you have spent 25, what are you left with?
You need it later. Let me know.